So probability is just the likelihood of an event occurring. How likely is this? What kinds of numbers should you get? Percentages. So between, like, usually it's written as either a percent or a decimal. So in decimal, it should be between 0 and 1, or 0 and 100%. 0% meaning it can't happen. 100% meaning it's guaranteed to happen. Impossible to have a negative or more than 100%. So there's something called the law of large numbers. It tells us as the number of trials increase, the probability will get closer to what we expect. Here's what I want you to think about. If I flip a coin, okay, what is the probability that I will get a heads? 50-50. Okay, 50% chance that I will flip it and get a heads. So does that mean if I flip the coin twice, I will get 1 heads and 1 tails? No. Even though we expect a 50% chance of heads, we know that's not necessarily what will happen. What if I flip it 10 times? Will I get 5 and 5? No. But what will happen is as you do this repeatedly, if I flip my coin 1,000 times, do you think it would be closer to 500 and 500? Yeah, and if we did it 10,000 times, it would be even closer. So if you're only looking at a few, the probability may not be what you expect. But large numbers, as you do more and more trials, it will get closer to what we expect. Sample space is the collection of all the possible outcomes. So if I'm flipping a coin, what are my possible outcomes? Heads or tails. That's my sample space. Okay, if I'm going to flip a coin twice, for example, if I flip a coin twice, my sample space is everything that could happen. So could I get 2 heads? Yeah. Could I get a heads the first time and then a tails the second time? What else could happen? Tails and then heads, or 2 tails. That's my sample space. That's listing out all the possible outcomes. An event is any collection of outcomes. So an event might be I flip my coin 6 times and I write down tails, 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 heads, heads. Okay, you're just writing down what happened. That's your event. So let's look at an example of this. So let's say we were looking at families with 2 children. What would be the possible outcomes in regard to gender? I should have been a little more specific. Okay. So we can either have a boy or a girl. So my sample space, if I'm talking about 2 children, what are all my possible outcomes? Yeah, boy, boy, girl, girl. Is that it? And is it different to have boy, girl than it is girl, boy? Yeah, if we're talking about the boy being the oldest child versus the girl being the oldest, that is different. Okay. What if I said, give me the event, have 1 boy? So out of my sample space, which of those are 1 boy? Boy, girl. Girl, boy. Those are the 2 events where there is 1 boy. So a few things about probability. We kind of already touched on the first one. It has to be something between 0 and 1, if we're looking at decimal form. And if I'm listing the probability of all my different outcomes, it always has to add up to 1. Okay, if I'm telling you everything that could happen, then when you put all those together, you should get all of the options, 100%. A probability model is a list where I list the outcome and the probability of each happening. So I'll show you one of those in a second. But first I have a couple questions. If something is impossible, what's the probability? If it is certain, guaranteed it's going to happen, 100%. A lot of times we'll just do decimal, so you could say 100% or you could say 1 if we're doing decimal form. unusual, we will touch on that a lot for the rest of the year, rest of the semester anyway. Unusual is anything that has a low probability of happening. There are different thresholds for what's considered a low probability. Different situations require different levels, but typically anything less than 5% is considered unusual, and that'll be the threshold that we use. So if it has a less than 5% chance of happening, we would call that an unusual event. So let's look at a probability. Suppose a bag of 100 M&Ms contains 12 brown, 15 yellow, 12 red, 23 orange, 23 blue, and 15 green. Create a probability model. So probability model is just a table where we list our outcome, which in this case we're measuring color, and the probability. Brown, yellow, red, orange, blue, and green. How do you find probability? And I actually did already give you the grand total here. I told you we had 100. So how do I find the probability of brown? 12 divided by 100. 21. Probability of a yellow. Probability of a red. Probability of orange. Blue. And green. That's my probability model. Quick check to make sure you did it right. Every one of your probabilities should be a number between 0 and 1, which they are. Second, what should they add up to? 1. Check that real quick. That's a good way of finding any mistakes. Make sure all of your probabilities add to 1. So if I ever ask you to verify if something's a probability model, those are the two things you have to check. Is every number between 0 and 1, and do they add up to 1? Any questions there? Okay, so there's different kinds of probabilities that we can calculate. You know, with flipping a coin. If I flip my coin, let's say I flip it 10 times, and in that I got 7 heads. So what would be the probability of getting a heads based on that? 70%, 7 out of 10. Okay, but if I just ask you what's the probability of flipping a heads, you would tell me 50%. So that's a difference. Are we basing it off what should happen or what we saw happen? And those have different names. So we can look at both. The empirical approach is what we see happen. Okay, the number of times it's observed divided by the number of repetitions. What my 70% there, that's the empirical approach. I flipped my coin, I got 7 heads out of 10, so 70%. So empirical is what actually happened in our situation. If I ask you to do this one, everybody read it and see if you can answer this question. So an insurance agent insures 182 teenage drivers. Last year, 24 of the teenagers had to file a claim. So what's the probability they file a claim? What'd you guys do?
29.26%.
So you get 0.1319, or you could say 13.19%. Alright. So that's empirical approach, just based off what we saw. Let's look at this one. A class of 52 students is playing Pass the Pigs. You guys ever played that game?
No.
Oh, we should. I might have to bring it in. You have little pigs, and you roll the pigs instead of dice, and your points are based on how they land.
It's terrible.
I love that game.
I say we bring it in.
Never heard of that game in my life.
Okay.
We should
Yeah.
take it
Hey,
back.
we
We
gotta
are
bring
going
it
to
in
have to-
next week during homecoming.
Is that the making bacon game?
No,
Bacon,
that's a
bacon.
different one.
I've heard of it.
Okay.
What?
Yeah, we're going
Yeah,
to play
that
Pass
part
the Pigs
that-
sometime.
Is that the fun?
Making bacon.
I had that game going.
That game actually does.
Yeah, we had
I
like,
love
we had
bacon.
the farm
I
game
heard
and
about
stuff.
that.
We never had anything like that.
Pop the
There's
pig.
my game.
I
Yeah.
love
That's
the farming
forever.
game.
I like
Pop the
short
pig?
games.
Yeah.
I don't have the attention.
Yeah, where you
Oh,
squeeze
the
the
farming
belly?
games? What I
Yeah.
do.
Yeah.
Or,
Yeah.
there's one we have in Terry's house. It's like my
It's like
favorite.
shove it, like.
Oh, farm life.
Or like the closed wall.
It's awesome.
I've seriously
Alright.
never heard of that though.
The bell.
It's
Okay,
like,
we're going to play Pass the Pigs at some
wait,
point.
what's the?
But if I say, use the results of the experiment to build a probability model for the way the pig lands. So these are the different outcomes. So we played Pass the Pigs a lot. Let's say we rolled our dice.
Leaning jowl.
Yes, it's like if it's landing on its snout with its 3 legs in the air or something.
Leaning jowler, that's what they call it.
It's a fun game. I enjoyed this.
The trotter.
So,
Razorback.
Well,
MIZ.
Razorbacks normal.
okay, so if I ask for the probability model, we're basically just adding onto this table. So you can do it right next to your table.
Where we at?
What would I need to do though before I can calculate the probabilities?
Add them all up.
Add them all up. We need to know how many times did we roll these pigs.
Yeah, too much.
Wow.
So you get 3,939.
Alright.
So then how do we get each probability? Divide. So 1344 divided by 3939. 0.3412. 1294 divided by 3939.
With probability, are we gonna have to do like graphs? Like what? Thank God. I hate graphs.
Now what should these add up to? 1. Is it possible that it won't? Yes, because I just rounded all these numbers, but I should get something very, very close to 1. So that would be an excellent way to quickly check. I can make sure, is every number between 0 and 1? Do they add up to 1? And mine added up to 1 perfectly, so lucky us, we rounded and that worked. So based on this, what's the probability that a pig lands on the side with a dot?
32.85%.
And you can give me the decimal or the percent. Just make sure if you give a percent, you put the percent symbol by it. Would it be unusual to throw a leaning jowler?
Yes.
Yes. Why?
It's still up.
It's under 5%.
Yeah, it's 0.8%, and anything less than 5% is unusual. So that is most definitely unusual. All right. So do you understand empirical? It's just what happened. Number of times you saw it happen out of the total. Classical is what we think should happen. So it's basically if I'm rolling a dice How many sides are in the dice? 6. How many of them are a 2? 1 out of 6. Okay, does that mean if I roll the dice 6 times, I'm going to roll 1, 2? No. But classical is what we would expect to happen. Okay? So, for example, let's look at this one. We have a fun-sized bag of M&Ms that has 9 brown, 6 yellow, 7 red, 4 orange, 2 blue, and 2 green. That's probably not a fun size. That's probably like a normal size of M&M. Normal bag now. Fun size is like 4 M&Ms. What's the probability that it's yellow? So, did I actually pick out an M&M and find out how many were yellow? No, we're basing what should happen. So how many total M&Ms do we have? 30. Okay, how many of those are yellow? 6. So 6 out of 30 gives me 20%, 22. So that's classical. I didn't actually do it, but based off what could happen, there's a 20% chance that I get a yellow. What's the probability of a blue? 2 out of 30. So what was that? 6. What was it? 0, 6, 6, 7.
0.06.
What's wrong?
You said 6.
Oh my. I thought we were past that. All right.
You said it. What do you mean?
What's comment on the likelihood of the candy being yellow versus blue? What would you notice about that?
More likely to be yellow than
Blue
blue.
is unusual and yellow is more likely. Whatever.
You could
Yellow is
say
more common.
yellow is more likely, blue is unusual. Oh yeah, it's not under 5, so it is not. We couldn't say unusual. We could
It's
just say
actually 6.67.
less common. Okay, 20% versus 6.6 repeating percent. All right. Let's look at this one. Sophia has 3 tickets to go to a concert, but Yolanda, Michael, Kevin, and Marissa all want to go with her. To be fair, she randomly selects 2 people. What's the sample space? What do I mean by sample space?
2 out of.
All the possible.
All the things that can happen.
Oh.
Okay. I don't know. Can I just abbreviate so I'm not writing my names?
Absolutely.
Okay. So I'm going to say Yolanda and I'll do MI for Michael. Or I could pick Yolanda and Kevin. Or I could pick. Okay, that's every combination with her. Then I could do Michael and Kevin. Or Michael and Marissa. That's every combination with them. Or we could do.
Oh my days.
Alright, so that's every way I could pick 2 friends to go along. So the probability of Michael and Kevin. How many are Michael and Kevin out of that? 1 out of 6. So 1 out of 6. You can leave it on these. You can leave them as a fraction in lowest terms, as a decimal, or percents. But if you do a decimal, just make sure you're leaving me like 4 decimal places. What's the probability that Marissa goes? Because we see she gets selected 3 out of the 6, or 1/2, or 0.5, or 50%. Any of those. Okay, if I ask you to interpret the probability, what does that mean? When I say 50%, what's that mean?
50%.
Marissa has a 50% chance of hitting it.
Let's look at this one. A survey asked 500 families with 3 children the gender of their children. It was found that 180 families had 2 boys and 1 girl. So, empirical method. Empirical, think is like what you see with your eyes. Okay, out of this, what was the probability of 2 boys and 1 girl?
180 over 5.
Okay. So that is 36%. Okay, classical. So, classical approach is what we would expect to happen. Okay? So we could think about this a couple different ways. We could list all the combinations. If you have trouble listing combinations, you can do like what's called a tree diagram. And the first child could be either a boy or a girl. Second child could be a boy or a girl. Whoops,
Boy.
I said girl. Or you can just list them, if you can come up with the 3, but this is, the third child can be, so some people like these tree diagrams. I don't draw them very often, but I wanted to show you, just in case you see one. So if I'm looking at this, how many total possibilities were there?
8.
So you're looking at that final branch, how many did we have? There were 8. How many of those were 2 boys and 1 girl? So we could have gone boy, boy, girl, boy, girl, boy, girl, boy, boy. Any other way? But we need 2
Oh.
boys.
Yeah.
So,
That's
3
all-
out of 8.
that's all you need.
Okay, what's that? 3 out of 8? 0.375 or 37.5%. So we can see they're different. Empirical is what we actually saw happen with our eyes. Classical is when we look at how many outcomes are there, how many of them are what we want. Do you guys understand the difference between empirical and classical?
Yeah.
The third type of probability is subjective. This is like the weather. When the weatherman says there's a 30% chance of rain. Is there any mathematical way he could sit down and calculate that and every single weatherman in the world would agree with him?
No.
No. They take into account, it's not just like me saying the probability of rain. Obviously they're educated, they look at all these factors, but there's a certain level of personal opinion involved there. Another one, like an economist predicting a 20% chance of a recession. Could another economist look at it and predict a different percent? Yes. So subjective is when it's kind of based on personal opinion, and there's a little more variability there. Those are the 3 types of probability. Do you guys have any questions? Okay.